To find the point on the graph where a slope, the gradient of a curve, has been given, we're going to follow these steps. So example 9, at what point on the graph for this function, so this is your curve, does the tangent line have a gradient or slope of 13? So step 1, we have to differentiate the function using our power rule. So dy dx, use our power rule. So 2, bring down the 2, x, subtract 1, plus 5, bring down the 1, and subtract the exponent. The last term is a constant, so that just becomes 0. Then simplify that derivative function. So 2 times 2 is 4x plus 5, and then x to the 0 power is 1. Step 2 now is to substitute the gradient, which our gradient was 13, into the derivative function and solve for x. So we're going to let x equal 13 in our derivative function. So we're going to replace that x with 13 and then simplify it. Oh, sorry, mistake. And for the dy dx. Sorry. So I'm going to rewrite this as dy dx equals 4x plus 5. We're going to substitute this 13 into the dy dx and then solve it for x. All right, so to solve this equation for x, we're going to subtract 5 from both sides. (13 minus 5 is 8. And then divide both sides by 4. So x equals 2. So again, in step 2, you take that gradient value and you substitute it into the dy dx. All right, step 3 is to now substitute the x into the original function to find y. So you're going to substitute that x value into the original. So I'm just going to change colors here. Here is my original function, and I'm going to substitute my x into that function. So I'm just going to write the function again. So here's your f of x, your original function, 2x squared plus 5x minus 3. And we're going to let x equal 2. So f of 2. 2, replace the x with 2 squared plus 5 times 2 minus 3. And then we simplify it. All right. So f of 2. So 2 squared is 4. 5 times 2 is 10 minus 3. F of 2 is 8 plus 10 minus 3. Simplify that. 18 minus 3 is 15. All right, last step. Step 4 is to write your answer as x and y. So this is going to be your y value, and this is going to be your x value. So x comma y equals 2 comma 15. Let's graph the function and see what we just found. So if we go back up, there was our original function that I have not highlighted in the green. It's a quadratic. The tangent line has a slope of 13. All right. Sorry. Oh, where'd it go? All right. So to bring this back down, what did we find? So the original function was a quadratic. Y equals 2x squared plus 5x minus 3. So if I graph that with my graphing calculator, it looks something like this. Now we have a tangent line. I'll put this in the blue. This tangent line had a slope of 13. And what we found is that that tangent line runs through the ordered pair 2 comma 15. So here's over 2 up 15, and then there's a tangent line that runs right along here with a slope of 13.